So now let's look at another example of using integral tables for something that's a little bit more difficult to work with here. So I've got the integral of x over x squared plus a squared to the 3/2 power and dx. So if I go to my integral tables from the calculus book, it is definitely not one of these that's under the basic ones. There's a few forms here. No, that doesn't have a square root, although that's got a minus sign and there's an x on the bottom. Okay, we come down here. Inverse trigonometry. Oh, things with a squared plus u squared. Well, that's kind of like ours. Okay, they do have one here, but no, there's no u up on the top, so it's not in here. So we're going to have to figure out what it is we're doing so that we can actually find a solution here. Now when I go to the integral tables here, again I run into a similar sort of situation that I can come down and I can find some of them, and I've got ones with roots in there, and I've got ones that have logarithms and exponentials and trigonometric functions, but I just can't quite exactly find the one that I want to find. So let's go over to that CRC table. And again, in this particular thing, we've got an interactive table of contents over here. So we go down to the table of indefinite integrals, and it's got a section on here, forms containing x squared plus or minus a squared. So I come down there and I'm looking again. I need an x on the top, but oh, that's just the one. Here I've got some that are starting to look a little bit more like mine. So I'm going to grab one of these here, and we're going to show that we can put ours in this format to be able to use it. So I'm going to come back over here and I'm going to paste this one down. And a couple of things for you guys to notice about these kind of things. So first of all, this one includes a couple of possibilities. I've got a plus, but it's got a plus or minus. So what that means is that if I've got a plus, well, over here again, it's plus or minus. If I had a minus sign, then I would use the minus sign. Occasionally you'll have one of these where on the solution it will have a minus plus, which means if you had a plus to start with, you've got a minus for your solution. If you had a minus to start with, you'd have a plus for your solution. We don't have to worry about that one so much, so we're able to go through there and say that. And the other difference here is that this one is to the 3/2 power, and this is the square root of this function cubed. But we know that that's actually how that works, that when I'm looking at the 3/2 power, that is the square root of the value cubed. So this is indeed the sort of format I should have. And so this tells me then that my answer should be of the form of -1, the square root of x squared plus a squared. And of course, I have to evaluate that from whatever my two boundary conditions, so from some initial x value to some final x value. So our CRC tables, we can actually find a value in there that's close to what we've got. But I also want to show you not just the CRC table, but our integral calculator. Now the integral calculator's been trained on a lot of things, so it's able to go through and do this. So I'd gone ahead and typed in this whole thing, and I'm going to say go, and it's going to calculate, and it's going to say, okay, this is the function I'm trying to do. This is the answer that I get. But I can have it show the steps here. So it will show you if I do a U substitution like this, that gives me here. And then again, you can look at more steps to go through and see how we find all of these individual little things. So I had to use a derivative in that particular spot in order to find that. And then I've got a particular thing, so I use a power rule, and it's a fractional power, so it goes through and plugs that in, and then we go back and substitute in back our original thing, and it gives us our form here. So this one does actually go through and give you a little bit more power in terms of seeing how the solution came about. And so this is, again, something that came from the interactive integral calculator. Now, again, if I needed to evaluate this at particular boundary conditions, you would plug in for your initial one and your final one. If you're using the integral calculator here, you could actually plug in and say, okay, let's say I'm going from 0 up to b, where b is some other value in my system. And then when I hit go, it's going to go through and it's going to show me again what my input is and what my final answer is. And so in this particular case, it's sort of showing me what that looks like. And if I wanted to see all of the steps again, I could see how it's going through and doing that. And it gives me my solution for the general form. And then it gives me the solution where it has simplified it, plugging in. And so we could grab that and then come back here and grab this as our form. So if you are using this just to be able to solve upper level problems where the situation may be kind of complex and the focus isn't on how do I do the math, but using the math to get an answer, then using something like your integral tables or your integral calculator is really a powerful tool. Now, if you're using this to shortcut in your calculus class where you're supposed to be learning how to do all of those, then I encourage you to use the full step so you can see what it is and use it as a tutor rather than just jumping down. Because in the calculus class, you're trying to learn how to do this, not just use the integral as a tool within another problem.